Hi, my name is Jordan Kaiser. I'm a design consultant with Northwind Solar. We here at Northwind are doing our best to adhere to the state's Safer at Home policy while trying to continue to provide our services to residents of central Wisconsin. Today I'm going to take us through a solar site assessment. The site assessment allows us to gather site details so we can accurately design, price, and install a solar power system for your home. Here we are on site at my home in Amherst, Wisconsin. And as you can see, I already have my solar power system installed. My rooftop array consists of 12 320 watt Solar World modules, bringing my total DC capacity to 3.8 kilowatts. But what we want to focus on today is some of the external characteristics of my home, of the building, and specifically of the rooftop itself. Now, if you can look closely, you see I have a standing seam metal roof. The seams rise up about 1 inch and are spaced approximately 18 inches apart. We're seeing this type of roof more and more throughout our area. One of the best traits of this particular roof, and considering mounting solar on it, is that we can avoid most all penetrations within the roof. We have a special dynamic fastener that attaches to the seams themselves and allows us to avoid the penetrations through the rooftop and into the trusses. Those fasteners are attached to the seams, the railing system is attached to the fasteners, and then the modules are attached on top of the rails. My system particularly is installed a little differently. As you can see, it's pitched up off the roof deck. Most systems we install these days are mounted parallel to the roof deck with no pitching. That saves in cost, as not only in materials but also labor cost installing the system. Other roof types that we commonly see in our area are asphalt shingles, as well as corrugated steel, and each roof type has its own approach to installing a rooftop system on it, and that's part of our job to make sure we're using the right equipment and getting it attached properly to the rooftop. Now, my roof is slightly shallow. I think it's at about 412 pitch. Some of the things to think about while we're looking into the rooftop are not only what type of roof it is, but what condition it's in. We want to make sure that the roof is sound and has no structural issues that would disallow us from installing the system. So usually we're getting up on top of the roof, pulling a tape measure, getting the dimensions of the roof itself, as well as trying to identify any issues we see, whether it's soft spots in the roof, any other issues that may prohibit us from installing on it. Additionally, we're getting inside the attic space to look at the trusses or rafters of the roof structure, and again, making sure they're sound and determining that the roof can withstand the loading that the array will add to the rooftop. Now, one thing to remember, the solar array itself is fairly lightweight. The array is built with lightweight materials, aluminum, stainless steel. The modules themselves, depending on the size of them, are 40 to 50 pounds a piece. All told, the solar array is going to add somewhere around 3 pounds per square foot of dead load to your rooftop. So most engineered structures, most engineered roof trusses will be able to withstand that additional load, as well as a lot of the older rafter structures of homes. Now, we do provide dead load calculations to determine that it can in fact withstand the loading of the array. And if there is need for additional bracing or fortification of the roof structure, we do that as well. Again, we want to make sure your roof is sound and that we can properly install the solar array on top of it. One of the other major considerations we review during a solar site assessment is shading and how shading affects performance of your solar power system. Shading is ultimately the arch nemesis of solar. When your solar array, and specifically the cells within your modules, are shaded, that's going to affect performance, either reducing or even eliminating performance until your array is free of shade. Now, over the years, new innovations and technology have allowed us to help mitigate the effects of shading on your solar power system. We also take different approaches within our designing and installation to really reduce the effects of shading. Obviously, we live in a wooded area It's not often that we come to a site where there's zero shading. Most homes have at least a few trees, and even if they're not on your property, they may be on your neighbor's property, as you see here. But ultimately, it's not often where we come into a site where solar just won't work. My site particularly is fairly free of shade. I did remove a couple trees when I installed my system to help open up my solar window. I have some taller pines out to the west that do shade my array late in the day, late in the year, November, December, January. But ultimately, my solar window is open from 9 a.m. to 3 p.m. And really, if you can have your solar access open during those hours, that's when you're going to produce your most solar energy. Anything prior to that or after that is sort of a fringe benefit. Ultimately, my site is a pretty good site for solar production. And again, with your site particularly, we help identify any shading obstacles and talk about how that may affect solar performance. Another consideration we look at during the site assessment is electrical integration. So how we tie your solar power system into your home's electrical infrastructure. Now, we're talking about a straight grid-tied system here in my home, and it starts with my solar modules on my rooftop. My modules are wired together and tied into my solar inverter. My solar inverter is then wired into my main service panel or breaker panel. In between the inverter and my breaker panel, my main service, is an AC disconnect. As you can see there, that's that little gray box you see above my electric meter. That AC disconnect is a requirement of the utility that allows them to shut down your solar power system in the event of an emergency or needed maintenance. And that's really the main components of your system. But what we want to look at is how we get from point A, your solar array, down to point B, your solar inverter. Your modules, your array will be wired together. Those conductors will be run through conduit, and that conduit will be run down to your inverter and connected therein. As far as the AC disconnect, we want to identify a location where it can be installed, make sure we have the proper spacing, look at the siding and how we're going to attach to the building, and make sure it's within the required distance of the meter. Different utilities have different requirements, and again, it's part of our job to determine what those requirements are and that your system installation meets them. Here is my solar inverter. This is the SolarEdge 3800 watt inverter. Now your inverter is essentially the heartbeat of your system. The inverter takes the direct current from your solar array, DC, and converts it to alternating current, AC, that we use in our homes. This particular inverter is comprised of not only the inverter itself, but also what are called DC power optimizers that are attached to each individual module on my roof. And what those DC power optimizers do are essentially a voltage regulator, and they help optimize the system's performance by mitigating shading effects and even mismatches between modules and maximizing power output from your solar array. This particular piece of equipment has been fantastic. I've had zero issues with it. We install a lot of them. But in terms of considerations where we mount it and how we mount it, we want to look at how much space we have to install the inverter, not only based on how big the inverter itself is, but also we have the proper amount of spacing between your main breaker panel and any other obstacles surrounding the electrical area. Now, my inverter is located in my porch area. My main service panel is in my basement, and we've run conduit down to it. So I didn't have a lot of issues in terms of spacing, but certainly every home is different. So again, we want to make sure we locate it in a code compliant area and that it's properly installed. Along with the main function of the inverter, my system and most all systems we install also have online performance monitoring. So I'm able to view my system's performance online by way of a mobile app on my phone, as well as any laptop or desktop computer. And your online monitoring is the best way to make sure A, your system is performing as you expect it to, but B, if there are any issues with it, you can be more quickly alerted to those issues, and we can then troubleshoot the issue and get it resolved as quickly as possible. Along with the inverter, and really the inverter is the uppermost component you see there. Down here with that black knob you see there is the integrated DC disconnect. What that disconnect does is allow us to isolate the solar array, the DC, from the AC, the alternating current. So if there's ever any need for us to do any sort of maintenance on the array, we can flip that disconnect switch and that'll power down your array and allow us to service it as needed. In most cases, that knob just stays in the on position for the life of the system. It's not often we're having to do much of any maintenance on the system, but again, is there in the event it's needed. Just to take a quicker look at my inverter screen. Now, depending on the type of model inverter you have, may or may not have an inverter screen. The older models of SolarEdge do have the inverter screen here, as you can see. These days, the newer SolarEdge inverters do not have a monitoring screen. All the monitoring is done online. SMA is another inverter we commonly install. SMA does come with a digital display on the inverter, as well as online performance monitoring. But as you can see, what we're looking at here is the AC voltage of the system. Oh, bring that screen back up. The DC voltage of the system, and my instantaneous power measurement in watts. Right now I'm producing 27, 26, 27, 25, up to 3,000 watts of power. Now that's obviously variable. It's all determined based on how much solar resource we have at any given second. Right now it's partially cloudy outside. We do have some clouds rolling through, as well as other particulates in the atmosphere, a number of things that could reduce production. So again, as the sun shines, that determines how much power we're going to be generating at any given moments. And a little further down, you see where it says POK, 12 of 12. That means I have 12 power optimizers on my rooftop, and all 12 are reporting, and everything looks okay. There are 3 lights on my particular inverter. The one you see in green represents power production. The next one down, where it says module communication, you'll see that blink every 15 seconds. And that represents communication between the power optimizers on the rooftop and the inverter here in front of us. And then below that, where it says fault, if there are any issues with the system, that light will illuminate red or reddish orange and alerts us that there's some sort of issue with the system. Along with that light, there's usually some sort of error code on the screen that we would see. And again, that's another way we can determine that there's some sort of issue with the system. Now, my screen allows me to scroll through and see other characteristics of the system. I see my grid frequency at 60 hertz and internal temperature of the inverter at about 84 degrees. So everything's looking good there. I can scroll further and I can see how many kilowatt hours I've produced today. So we're sometime early afternoon at this moment, and I've produced nearly 11 kilowatt hours. You can below that see my monthly totals, annual totals, and cumulative lifetime energy produced. And then further throughout the inverter, you can get a little more in depth with other identification and hardware numbers, different pieces of information, most of which can be found online on your monitoring. But if you happen to be out near or next to your inverter, you can quickly see how your system's doing. So that's a quick rundown of the SolarEdge 3800 watt inverter. This is my main service panel or breaker panel located in my basement. Now, the main thing we're trying to identify is how we're going to interconnect your solar power system to your home's electrical infrastructure. There are 2 main ways to interconnect your solar power system. The first being by way of breaker interconnection, where we'll take up 2 breaker spaces within your main service panel, and the power flows from your modules through your inverter and distributes into your main service panel. Breaker interconnection is how my system's tied into my main service panel here, and I'll show you that in a second. The other main way of interconnection is by a way of line side tap, where we are actually going in and tapping or tying on to the main service conductors coming into your main service panel. On the outside of the panel, you can see my system is labeled. I have the identification of a dual power source, meaning we have both utility power and PV or solar power coming into the service panel. So anybody looking at this, any electrician or utility representative, knows that there's power coming from 2 different sources. Below that, you see the PV interconnection breaker, identifying this as a breaker interconnected system. As mentioned, this is my 200 amp service panel. The main service breaker is located up top. You can see that's 200 amp. Down below, opposite of the main breaker, are my solar breakers, and that's where my system's actually tied into my electrical infrastructure. I'm tied in by way of 20 amp dual breakers there. Now, my service panel has plenty of room. As you can see, I have a number of open spaces, but not every house is like that. Many times we'll go into a home and the service panel is completely filled up. So in those cases, we look to do, well, a number of things. We can sometimes put in tandem breakers and open up a couple of breaker spaces to interconnect the system, or we can do what I mentioned, being a line side tap. In addition to the amount of room on the service panel, many times we'll be taking the cover off the panel and just looking at the guts of it, making sure everything is clean. We have a good working area. There's no red flags or issues with the electrical. We also want to take a look at the amount of room we have within the sill box area, make sure we can get conduit down off the roof and into the basement so that we can connect into the inverter, and that we can connect the inverter to the main service panel, and so that everything's done code compliantly. Ultimately, this is a fairly straightforward system. It's a small system. Certainly, as I mentioned, every house is different. But again, it's part of our job to identify how we're going to go about interconnecting your system and making sure it's done in a code compliant way. I hope you found this video helpful. Give us a call at Northwind Solar today if you'd like to schedule a virtual site assessment for your home. 715-630-6451, or you can find us online at northwindre.com. We look forward to working for you.